everyone, and welcome back to Activity 17. Today we are going to talk about graphing cosine and sine, but with a period change. So we talked a lot about parameters A, C, and D in the previous lesson. Today we're going to focus on the horizontal stretch / compression, aka our period change. So what we do each time to find the new period, the amount of time it's going to take our graph to repeat, is take 2 pi divided by the b value, parameter b in our graph to see the new period. So each time we're doing a lot of the same things we were in the previous lesson. We're looking if there is an amplitude change. In this case, we will be stretching by 3 this time. So our amplitude is now 3 instead of 1. This time our b parameter is 2. So if we take 2 pi divided by our b value of 2, we would have a new period of pi. So this is going to be shrunk down and repeat quicker than our normal graph would. So if we look at like a comparison on these two, for instance, we would take 3 sine of x versus 3 sine of 2x. And we then can compare these two graphs on a normal graph. We're going to see that compared to the original, this one's going to repeat quicker. It's going to be horizontally compressed and kind of repeat in half the time that it would take our normal parent function there. This time there is no phase shift though, left to right. There's no parameter C. There also isn't going to be a vertical shift this time. We just are going to have a midline through y equals 0. Now on our graphs, the biggest change you are going to see from what we were doing in the previous lesson is that instead of repeating by the time this graph gets to 2 pi, it's going to repeat by the time it gets to pi. So if we divide our period by 4, that's going to be the new scale on our graph. So we have 1 pi over 4. 2 pi over 4 would reduce to be pi over 2. 3 pi over 4. 4 pi over 4 would reduce to be pi. So we see the scale on this new graph. And then it's going to be graphed very similarly to what we did before. This time our sine graph will start at the midline. It's going to go up the amplitude to the maximum, back to the midline, down to the minimum, and then back to our midline. So we see our stretched out graph. So to the eye, it's going to look very similar to what we did yesterday. But again, if we compare it, because we shrunk that period scale down, it's actually repeating faster. We just changed the scale on our graph to make it a little bit easier for us to graph. On our next example, this particular sine graph is going to have a new amplitude of 4 because it's being vertically stretched. This time our period, if we take 2 pi divided by our b value this time is 1 over 2. So we would take 2 pi times the reciprocal of 1/2, which is 2 over 1. 2 times 2 is 4 pi. So really what's happening on this particular graph is we're actually slowing things down and it's taking more time to repeat. It's going to take all the way to 4 pi. So it's going to take double the time we're used to repeat, and our scale is we're going to go up by 1 pi each time if we divide by 4. Again, there is no horizontal shift on this one. There is, however, a vertical shift down 2 units. So we would see this through -2. This time our sine graph again starts at the midline, and this time it's going up 4 units from that midline, back to the midline, down 4 units to the minimum, and then back to our midline. So we see that shifted and stretched sine on that one. All right, our next one is going to have an amplitude change of 3. This time, again, we are having a b value here of 1/2. So similar to the previous problem, 4 pi is going to be our period. This time we are going to shift our graph to the right pi. There is, however, no vertical shift. So we're going to have our midline through y equals 0. And again, similar to our last graph, these are each going to be shifted. We have to repeat by the time we get to 4 pi. Now, cosine starts at the min or the max. So be careful on this one because of the reflection. We're actually going to start at pi, but down 3 units since we're starting at the minimum. Again, remember the horizontal shift, so we had to shift to the right this time. Up 3 units, back to our midline, and then we're going to have to kind of extend one direction or the other to see one full cycle of our graph. And then the last one on this page is going to have a couple things happening. Amplitude of 4, period. Again, we're dividing by this b value of 1/2. So again, 4 pi. No horizontal shift, but up 1 for a vertical this time. So as we calculate these through, again, this time repeating by the time we get to 4 pi, going up by pi's each time on that x-axis. Cosine is going to start 4 units above at the max, back to the midline, down 4 units from that midline to our min, back to the midline, and then back up to the max. All right, the last page has 2 more examples for us for these notes. This time, checking our amplitude, we have 2 pi over 3, because 2 pi divided by our b value of 3 is just going to be 2 pi over 3. Horizontal phase shift left, pi over 6, and then down 3 units for the vertical shift. So a lot happening on this particular graph. So again, we usually like to start off graphing that midline and then setting our scale. So this time it's kind of a tricky one because 2 pi over 3 is going to be our time it takes to make one cycle. So think about if we took 2 pi over 3 or 2/3 and divided it by 4, each of our pieces is going to be going up by pi over 6. So we have 1 pi over 6. We have 2 pi over 6, which is actually going to reduce to be pi over 3. 3 pi over 6 is going to be pi over 2. And then we have 4 pi over 6, which reduces to be the 2 pi over 3. So again, if you keep thinking about like, oh, hey, we're adding 1/6 each time, we see the 1/3, the 1/2, the 2 pi over 3. We just have the pi's then, which you do those. So kind of a tricky scale just because we're not used to using that. And then we're also going to be going to the left to start off on this graph. So when we graph this cosine, we want to make sure we start to the left and then 2 units above the midline to start. And then back down and then up to each of these pieces. Our last graph is going to give an amplitude change, a period change, which this time is b value of 1/4, which means this is going to actually stretch to be all the way to a period of 8 pi. We have a horizontal shift to the right, 6 pi, up 2 units. So this one's going to be very shifted around. Scale this time, we're going to repeat by the time we get to 8 pi, divide that by 4. Each of these go up by 2 pi, 4 pi, 6 pi. And again, if we are moving to the right all the way to 6 pi to start for this sine graph, careful of the reflection. We're actually going to go down to start. And then again, we have to extend our graph out to see one full cycle. So either we're going to be a little off the graph if we choose to go to the right to finish out this reflected sine. Again, you always have the option to go back to the left as well, since this is periodic. It moves both ways. All right, thanks everyone for watching. We'll work more at these in class.